Let's go! Hello, everyone! Hello, 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 Gizzy. Hello, Zaki. How are you? Yes, it's Sunday again. The last bit of the weekend. I hope everyone had a good one. Nice weather, not too cold, not too hot. Yes, a nice and relaxing weekend. Let's not talk about it. I'm so sorry. We should maybe just hop into Unreal Engine and do my super dry and data heavy work today. Maybe that gives you some other feelings. So let's just hop into Unreal Engine and I'll show you what I got. Yay, Monday! Where's my... You mistyped pet rock. Yeah, now it's working. It's important to have a pet rock. I love him. I really love this rock. Easy, we need to print one with a magnet that sticks to my shoulder. And I still need to make me a Tamagotchi type pet rock. That would be so cute. Oops. That was not intended. Seems like there was some love in the air. Yeah, so much love. I quickly check some stuff here, then we can have a roundup about what's going on here. Oh my god, Gizzy, you had a stream series of 5 streams. Lol. How, just 5? How did you manage that? Anyway. Yeah, I don't know either. We are here in my test level. Hello, test level. And there's nothing, just a bit of ground. One little deerling. Some grass, because yeah, I love the grass here. And my play stuff. In this case, it's a demo blacksmith building with a grinder, anvil, blank, and a cooling crate. And we are going to use only the blank, the crate, and nothing else today. I was just asking, what are you doing on Twitter? What? So our plan for today is to create a little system where we collect the data from your blacksmithing, and we put the blade into the crate, and when we hit the surface of the water, then we are swapping the blade for what we want to build. And to have that, I will move some stuff. Let's bring the crate just here. Whoops, not 90 degrees, but a little less. Because I want to try as much as possible without going into VR, because this section, what we are doing right now, should be completely data driven by itself. That should be possible. So let's see, we got this little blank master. We need to open our edit mode. There it is. We need that cooling crate in case that we need to change something about it, but most of the stuff will be done and working inside of our blank master. And third one that we need to make that happen is this wonderful file that is emptied. I called it DT, that stands for data table, and blade recipes. And what a blade recipe is pretty simple. We have different sections on our blade, Can we make them visible? Not here. Are you sure we can see it somewhere here? Developer bones, yes. Yeah, my blades have bones. So in this case, this is a short blank, and we have 3 sections. Section 1, Section 2, Section 3. And these bones help me to deform the blade as you work on it. And we have for every section 3 different values. The one is bending, that can be -1, 0, or +1. We have width left, we have width right, and that goes on for the others, like bending plus minus, width and width. Same goes here, bending plus minus, and width to each side. And that is stored inside the data of this blank. And as we put it inside here and touch that water level, we are going to read that data, and we compare it to our data table here and check which of these blades could be the closest to what we've done. And yeah, we will create some sort of level system to see some sort of comparison, and hopefully we can get the blade that we wanted to make. As you can see here, these are the blade meshes that we had in mind for the small one. We got some X type. That's not a proper X like for the wood cutting, for example, but more of an war axe. It's a bit more heavy on the front part here. We got that so-called flame burger. It's a bit like a snake or like a tongue. One simple straight radius type, a big knife type that is only done on one side. We have the short needle. This can be some sort of short rapier type weapon. Maybe we can make something else with it. Then we have the ox tongue. It's pretty pointy at the front part and gets super heavy and wide at the base. And I thought a sickle type would be cool as well. So this is the 1, 2, 3, 4, 5, 6, 7th blade type that we can get out of that one little short blank. We have a medium blank and a large blank as well. Those have way more and different blade types. So there are things that will be similar, just bigger. For example, the flame burger has just more wigglies on it. The gladius has a bit more of decorations on the go, and so on and so on. And this little baby, like the chop, it's getting super ridiculous and fun. I hope so. So we have like 7 different entries, and for that I will make one. Please end. Unreal Engine is not talking to me anymore. Here we are. 7. Now we can talk about the different values here and what we need to put in there. Okay. Let's shorten you here. Match tolerance. Targets. The finish blade value will be pointing to whatever target we want to have. This is the mesh of the collection down here. We have allow mirroring. This is only important for 1, 2, 3, 4, because you don't know which is like the left or the right side, since you can swap the direction of your blade whenever you like. So we have to check these that are asymmetrical on either way. We have to match tolerance. We can be super strict in some cases, and some can be pretty loose. Match tolerance says how far or how close you need to get to the perfect score to get this outcome. The segment targets, this is the recipe of each of these segments, like what we want to see there. Segment count, this is needed because we have like the different blade length. So we are only comparing, in this case, 3 segmented blades. So you're not getting a super large blade when you're working on a super small blank. Display name. If there's any case where we like type it, we have the blade ID. This will be like some sort of internal stuff. And a row name, which is just naturally created due to this data table structure. Let's try and see what I can get there. Finished blade, like this is where we want to go. Select an actor in the viewport. What can I put in here? Let's see. Maybe we need to change a little bit. In this finished blade actor, but not a object reference, but more class reference. Let's save this and see if it's changing something. Yeah, now we can select this. So the easiest way is that we just we take the easiest first, like the symmetrical ones, and then we get to the asymmetrical ones. I select this one, click in here, and then we have this little arrow down there that should be mod. Thank you. Actor. Oh yes, I did actor here, not mesh. I'm here in the mesh folder. Sorry. So we have to see if I already created actors, and if not, then we have to. I'm pretty much sure I at least created one. Let's go here into Campfire, blueprints, items. I think it's here blades. Yes, so we got some base blade. I will make a child blueprint class. Blade S underscore radius. So this will be, yes, the main shape. Let's save this one. And this will be our first selectable now. I hope it's working. There it is. So this one is saved. Means we have to create more of these child blueprints based on the meshes. Blade S. The chop is definitely here. You're on a skeletal. I remember. I think we needed the skeletal mesh for the sharpening effect to get the vertex done. So let's see. Meshes, assets, blades. Those are the soul static meshes. We'll quickly check if they are needed here or not. Blade component. Let's edit this one. Are we looking? Yes, we are looking for a skeletal mesh. That's okay. Scala parameter, value, material. I wonder, scala parameter, value, material. They should work on simple meshes as well. Do we have Yeah, there's this static mesh, like the holding part. But I wonder if we can go cheaper with a not skeletal mesh. Let's add a static, just for a test. Quick check. Static mesh. Go here, just with everyone else. I want to hide you. You're not visible anymore. And we have that static mesh baby here. I'll correct everything here to 0. And the scaling goes to 1, 1, 1. And then we see if we can give that baby just this. If it's working, if it's doing. We are taking the Osal blade material here, put it on top of that, and just make a test. You opened and okay, this is what I wanted to see here. It's black because it has no data about its appearance yet. I want to see it in the bright light of the sun. Keep positioning it here. And when we do some, as you can see, this part is changing its color. That upper one not, because I assume it's looking for that part that is a skeletal mesh. Get basic values. Let's see. Sharpness here, skeletal mesh. It's looking for that one. And we are now going for a static mesh and see if it's still working with us. And not only that, static mesh. Get component by class. Oh, it's getting just one component. Components by class. Static mesh component. And then I will loop that baby here. Each loop. So just putting that in between. Loop body goes here. And that's inside here. That's number 2. And blade is blading. Now to the sharpness. Blade component, can we see something? Text, alloy, nope. I go inside of that. Here's our sharpness. We open the eye so we can see it. And the sharpen value gives us this baby here. I'm quickly checking when we are spawning that blade if we are getting already the sharpness, so we can play with that. Getting the alloy stuff. Yes, it's selecting the sharpness part, so easy peasy. We are having blade component sharpness 50. No. You don't want to be edible. Oh, okay, 1 is the maximum. So I'm making you like this. Let me look for it, but I can't see any sharpness on you. Oh, blade component sharpness. Maybe that was the case. Oh, but this baby here is sharp as hell now. Maybe it's the same case, but it means that we can do sharpness on the single static meshes. That is great, but we are not looking for components by class here for the sharpness. I am giving, not Blind Master, Blade Master. Need to edit this one, and it will like adapt to everyone else. I only did it yet for that one. So we copy you, go to the blade base and add this. Viewport should show us 2 now. If I'm hiding that one. It's somewhere down here, visible, yes. When I click on it, then we are clicking the static mesh, bingo. Is that the opposite of your kindness dagger? Yes, a bit. Imagine you place a sword with a dull blade and a sharp handle, and whoever wants to steal it gets hurt. That would be so evil. But yeah, no, we don't need that. Okay, means we can get rid of that one. I don't see any use of having that. Nothing else should like work with any parent sockets. Let's quickly check. Then we can easily just get rid of that one. We have no animation blueprint here, so there's no need to keep that. Boop. And we're keeping just the static mesh. That is totally fine. And to make the difference between the handle and the blade itself, let's give it a tag. Blade. That's all. So back to the blade component. We are not only looking for a component by class. I am looking for a find component by tag. This will be our new source. Component by tag. Wait, what? Oh, component class, definitely. Static mesh component. And blade is our tag. Bingo. So this is clean now. Sharpness is only adjusted at blade level. And in this case, we can delete that because both of them are now static meshes. We're going through the loop and we color them both. In the sharpen part here, get owner, no skeletal mesh, but component by tag, static with the blade tag. Bam. I will copy you now because we will have the exact same setting here. So no need for you anymore. Compile, save. Let's test you. So this baby is not properly shown yet. Are you having blade component sharpness by 1? Pretty much sure the sharpness should show here since it's done in that one, and the blade base part was a static mesh as well. Maybe it hasn't worked here. Let's see. We done that on the blade base. Now let's go to the gladius. Ah, here we are. Which one is the one that belongs to? Yes, the static mesh component. I think that's the one that we are using here. Or the one with the tag? Yes. Ah, yes, here we are. The other one was overlapping. Ah, I see a little thing here. It's completely shiny. Yes, yes. Testing the shininess. If I go here to the Blade Master, I'm hitting my backwards. The static mesh is back. That part is back. And just for the test, we are using that get basic values here. Static skeletal. Sharpness. Radius. You have your baby here back. I'm hiding that one for now to see if that was the thing that I wanted to have here. Yes, and we make you visible again. Well, that's not shiny here at all. Check on blade component again. Sharpness on the skeletal mesh. It should do something. Yes, I'm just checking if there are any better ways to do that, or what's the most stable version to get this really done. As you can see, there is not much shine to that. It should. Oh no, sharpness is here on 0, sorry. Let's stop here and blade component, sharpness 1. Ah, that's what I meant. So, okay, boys and girls, this is the difference. If we are using a skeletal mesh, as you can see, only the blade part is getting sharp. If we are using a static mesh, everything gets sharpened. So, Gizi, what's more important to you? Do you mind if it's all shiny on the blade part, or do you want the you want to stay with this? Okay. Then we have to create every blade as a skeletal blade. They just need one little bone to get this effect work. But that's okay, then we know exactly what we need here. I'm quickly saving everything that's unsaved yet. Going into that folder. So here are the blades. This is skeletal mesh. I will make a new folder. And then I'm moving those two babies here into skeletal. Move here. And inside of that one. We can still use them for like props that we hang on the wall or something else. But I will now export each and every one of these blades as skeletal meshes so we can use them there. This is an unfortunate extra step we need to take, but it's definitely worth it, as Gizi has seen. With the middle mat, it will look better than you start to mix materials and add other stuff. Yes, definitely. This will add a lot. And our baby here is, do we see the blade component? The alloy just has now sand or salt. We can mix it, give it more alloys. Hello? Can I add a new key to the map while the key in the default value exists? Ah. It was sand! I am in love again. Yeah, that's nice because that's not loading anything. But as we trigger the value, then we have a total. So that's fine. Okay. I will quickly open Blender in the background. It won't take too long. Just adding one bone to each blade and export them one by one. That shouldn't kill us. Give me a sec. Open reason. I hate that the window of Blender is always so big when I open it. Starting Blender makes it so huge. So now on to Blender. Oh, again. Warp in navigation. Let's hide everything here. Where are you? I'll hide you as well. So this is our blank canvas. We have the three different sizes here: short, medium, and large. I'll show all of them. Bum, bum, bum. Boom. That's quite a lot. Yeah, now we have already this baby here with one wonderful bone. Should name it properly maybe, so we know where what to find here. We can hide you since you are done. Next one, and yeah, to make them properly visible, I will definitely have to turn them around, make them standing up, like not in this direction but in this direction. But a rotation by 90 degrees ain't that of a problem. I just hit R for rotation, then X because we want to rotate it around that red line. So R, X 90, boom, and that is. I'm going to add a armature here. It is. I'm locating you at this position. Bingo. This is beautiful. Edit mode. Shrinking that baby down. The size doesn't matter in this case. Because we don't use the bone in general. I'm just selecting now bone and blade, right click, parent, and armature with, I I think it's automatic weights. We're not using the weights really. Now this is an armature. Looking good. Seems good. Yes, we have now the vertex paint, the weight paint, and the texture paint. So when we're looking inside here, don't have any shape keys, vertex groups. Yeah, everything 100%, just to be sure. Yes, I think we can keep you like that. Can I hide you? Yes. Armature belongs in here. So that looks correct now. Where are you, my love? You're inside here. Perfect. Next one. Take you. Rotation X 90. Standing good and straight. Our lovely center point was a bit wrong here. Oh, you're not positioned correctly either. Let's quickly check the other one just to be sure. Job. No, you were great. You were a good one. Good boy. You're good, but my thickle is not. It is. No. We need a very good and perfect position on that one. I'm quite sure about this positioning. Let's fix that. There you belong. And now we add an armature for you. Pack you in here. Repositioning. Edit mode. Shrink. Thank you for the wood. Oh, both selected, parent. Automatic weights are okay for that. Thickle. Yeah, I made it. I reached the... Oh my gosh. So many crystals. What are you doing with them? Eating them? Thickle can be hidden. Who's next? Ox tongue. Okay. Rotation X90. You're sitting great there. Wonderful. Add armature. They're mine. Okay, I get you. So 1 and 2. Parent with weight. Hooks. Hidden. And hidden. Because we don't want to get distracted here. You're sitting great there. Wonderful. I love that one. You're getting my wonderful armature here. Bam, ba-dum, bam, bam. Yes, perfect. Put you up here. And it's 1 and 2 and parent. you a knife blade because it's knife shaped. Next, the flame burger it is. I love that one. It's looking so crazy. One and two. Pair it with weights. And here we go. Height and height. And last but not least, and that boy has to be centered as well. Now they are perfectly aligned. Pair of automatic weights, perfect. Same group. Needle S. No, that's good. Beside of the gladius type, we can now show everyone else. So we just skip that. We already have that one. Let's make all of them visible here. Perfect. I'm selecting all. One of them is not properly set. Better. That's a cursed weapon, yes. It's the all-rounder. The army Swiss knife. So I am exporting as FBX. Blacksmithing blades. We are exporting mesh and armature. Only the selected objects. Armature, no leaf bones added. That should do. I just call it blades S. So then we can import them as one set. So done. Quickly saving here before we return to Unreal Engine. So here's skeletal meshes. I'll quickly open my folder. Can't we just go inside there? I don't think so. To my Google Drive. Yay! Meshes. Items, blacksmithing. No, not that one. I'm gonna save it. Meshes, blacksmithing blades. Ah, there we are. It's S. That should be the right one. Import. Let's import. Let's see. Is skeletal mesh? Yes. Import mesh. Import everything. We don't need any materials. Do not create material. Import all, and let's do fingers crossed. Yes. Yes. I am trying to merge bones. It did nothing. Great. That's super great. But why? Maybe I have to export them bit by bit. That would be a bit jarring. Let's try it. Let's do it one by one. Oh, I hope we could do like a bunch. Hello, Agripeter. Oh, sickle. What's still left? Got the chop. That's the ox tongue here. Here we are. So we got only 2 now. That armature baby. And that. Selected both. Let's see if I can do that better. In Blender. All XPS. That it this way. Drop S. Mesh and armature, only selected objects. Put it XBX. Let's try it again. Bum, 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 bum. What all? That's only a static mesh. That's not good. It should export correctly. Let's kill the parenting then. Parent. Clear parent. Let's try it again. 1 and 2. Parent. Automatic weights. Why did you not properly? Armature and mesh export. Name is correct. Apply units. Let's just try to override it. I said it's going to take time. So again, we're importing everything skeletal. It's trying to import the same one. Maybe because of that existing skeleton in that folder. Maybe that was the issue. Import all. There we are. So we need folders for everyone. Move. Mesh incompatible skeleton, assign compatible skeleton. Okay. Oof. Maybe I can just bring all of them into that folder. And we blades S. Import all. Let's see. Skeletons, but no skeletal meshes. It's definitely wrong this way. So we can't do them in a bulk. That's sad. Means quickly hopping into Blender, and we first export one by one, and then I will import them one by one. So next up in our list is the flame burger. Let's try to import you like this. Export, sorry. Or you flame burger. S. Export FBX. Next one. Hide you. Let's re-export just to be sure. that baby here as well. Since there is still the option that it maybe killed something when I try to override them. Next one, the knife shape. Select. Can I hide you as well? I export. And you are called knife S. Check. We got the knife correct? Yes. Next one. The needle. Needle in S. The ox tongue. Saved. Last but not least, Mr. Sickle. Sickle. So, saved. Let's import them. Whee! New folder. Ox tongue. I just took this one because, yeah, reasons. Now we got them. That's great. Do we have sickle? Oh, there's a K missing. Import, yes. Boom. Next, a needle. Here we go. Okay, since we know that, that's a lesson, a learning. The knife and the flame burger still are missing. Knife. Import all. And the flame burger. Import. Boom. That's good. So content browser seems to be happy now. Let's go. It is. Are you still doing fine? Let's test you. Yes, good. You're great. You're fine. Content browser can be closed now, like this. And we're going inside of that order. Like here is where our different plates will be created. So this will be the new base we're working on now. For that job, now I can swap it for that job S. We have a basic material, but it's not the OSAR base. Boom. Should work fine now. By the way, that thing will be down there, will be swapped later on. Like there will be some sort of key and keyhole system that we had planned for different shapes of these pins and different shapes of handles that work together. We thought that would be fun to have some sort of variety. Yo, next up, we're going inside here. Now we duplicate you. Chop. Mirrored. Bum, bum, bum. 1, 2. I'll definitely work on that part later on, like where the hurting part will be. For now, we just need the different shapes to work for us, and the rest will be fine. So next, child blueprint. Laid as hamburger. Yes, nice, Zaki. You have water drops. You're making such a progress. I'm curious to see it. No. That's the right one. Yes. So you are done. We need a copy of you. One side and just rotate you as we did with the other one. Boom, boom. Safe. Can be closed, can be closed. Next child. Let's make the needle. You don't have to be mirrored. Should have selected that one. Also a base. Boop. Thank you, thank you. I'm really looking forward to see it. So Zeki is streaming when? I really want to see how this works. So what else do we need here? 1, 2, 3, 4, 5, 6, 7. 2 are missing. The knife. Knife baby. Oh, this is done as well. Side base. We need a copy of that knife since we can mirror that baby. Duplicate. That's all part of my work. So this. And what did I miss? Flameburger, gladius, knife, needle, sickle. The sickle is missing. S. That material. Save. And duplicate of that one. Compile and save. Let's count them again. We got 1, 2, 3, 4, 5, 6. Thank you, Zaki. One is missing. I have to quickly check my list. Oh, is missing. Oh, is missing. We see it fastest way. I quickly look into Blender. Top, Flameburger, Gladius, knife, needle, the ox tongue. Sure. S and ox tongue. At least this one does not need to be mirrored. Also base material. So this is done now. Oh, finally. Now we can fill that baby. But let's set up stuff in here. You are Gladius S. You are the first one. For display name. Short Gladius. We can have later on polls how we are calling them, but that's something for later. So we need 3 segments for that one. Open you, open you, open you. So index 1, this is like the base, the down one. We have on all of them a bending of 0 because the radius is pretty much straight. And we have data with left 1 and 2, left, right, with left and right, sorry. The value is between 0 and 1. 0 is like the short one in the direction of needle, and the 1 is something like the bottom part of the ox tongue. So the Gladius is pretty much in between. Let's do maybe 0.3 on both sides. Or let's make the tip a tiny bit less thick, like this. Match tolerance. (0.2). This one should be relatively easy to get. We don't allow mirroring, so we are not looking for a mirror counterpart. Next one. Blade S will be the next, the chop. Chop S. Short. Battle Axe. Segments 3, 1, 2, 3. Match tolerance. There's 0.2 again. we allow mirroring. So in case that we see the same thing working on the opposite side, then we are allowing that as well. In that case, I would say we have now everything on the left. So bending is all 0 and with right will be all 0. And I'm just giving the bases a 0.1. Middle part gets a 0.1. And the left top part gets a full 1. So this is the thick part. We can maybe check on that one so you can see it. So the idea is you have slight increase of width on that side, slight increase of on that side, and the full increase of width on that side to get this shape. So this is full, this is a bit, nothing on that side, and then you will have this baby here. So who will be next? Late as Flameburger. Well, this will be interesting. Number of segments, you've got 3 as well. 1, 2, 3. Okay, chop tolerance is here as well. I think a 0.2 tolerance could be good for the start. We will see then in proper VR tests later on if we need to tweak that. So in this case, we need just a tiny bit of width left and right. Let's say it's about 0.2 on both sides. We can make it 3. Then we have something more to do. And 3. Now to the curving. Do we have an open Flameburger somewhere? Nope. Let's go and open that one, the original one, so we can decide what to window port here. So it's pretty easy. We have a bending of like +1, -1, +1. Because it goes this, this, and this. So we have bend 1, -1, and 1 here. Ta-da! And that's how we make that Flameburger baby. Yeah, I know Zeki's getting hungry because I'm talking about burgers again. I'm so sorry. I'm sorry. The knife is the next one. I promise it will be easier. Knife S. Short knife. Segments 3. So 1, 2, 3 again. Make the tolerance 0.2 again. We allow mirroring because this is a one-sided blade. We are only making the left side 0.3. 0.3. And because it's getting like thinner towards the tip, let's make it just 0.1 here. We'll have to see later on how many hits we need to do. Okay. Next one. Latest knife, the needle. Needle is one, two, three segments. You're not mirror, blah blah. And this one will be easy because it's like a 0 on all. This should be the easiest one. Maybe we should be super strict here. So you're only getting that when you're fully into that. We don't have any negative material on the width side yet. So we will see. Latest box tongue. Yes. 3 segments. No need for mirror. And here we're going straight. We need on both sides a 1 here, a 0.5 here, and we go maybe really down to 0 to get the full tip. This would be so cool. So let's see, who's the last one? The sickle, of course it's the sickle. Sickleless. Short sickle. 3 segmente. You need to be mirrored. Okay, sickle is again, oops, 0.3. Skip, yes. 0.3. And here it is 0.2. And now to the bending, we have a sickle here, so we're getting full right, left, I would say. So full right, left, and left. That's it. That will be interesting. Let's close all of them. Need to tidy up our workspace here a bit. And this structure is okay, we don't need it anymore. Blade base can go for now as well. Keep as the blank master, the cooling crate, and we are opening the forgeable component. This is where we decide what to get. And I see I have somewhere here, I think, server finished piece. So this baby here, for the start, just delivered the blade base. We haven't had any item class input here. So let's see where this is coming from. I am finding the references. So we are getting it from here. Server finished piece, finish item. I think it's just the core from the cooling crate. Yes, just finish item. So this is where we start to ask what we are having here. And then we can tell what the baby will become. I would say we create a recipe database. Recipe database. And we can work from that on. DT. Isn't it called data table? I'm not getting that. Not structure. I'd love to get this structure. Maybe I can just bring it in there. Create components from asset in a non-actor blueprint. Oh. Okay, okay. Then we need to get this one in here, I assume. Maybe you want to be like here. Let me work with that. A note from this type of asset. Maybe we can make a variable here. Or just db for now. Data table. Okay, let's quickly check what I need to do to use that. So I wanted to have it as a helper here, because that would be helpful. No. Quickly ask my little friend and helper. Let's see if we can find something there. I'm sure that's a trick. I got the struct. And I have the component blueprint. The data table. Let's make a new one. I can crack gear like that. Okay. Database recipes, not Resident Evil recipes, but like this. Okay, cool. And we can select it here, what kind of database it is. Okay. Nice. Now we can look that. I will create a function here to determine what we are having, and then we are giving that data to this little function here and fill the item class with what we need. So our input will get a blade, and you are an actor. Actor, class reference, getting inside here. So this is already prepared. This is fine. And now we are creating the new function. Select blade. That should be okay. We have metal heat damage, general, forgeable, forge bonds. Here's the forge state. This is exactly the same thing that we are having in our data table. So this is what we are like getting from, and you are, as you can see, this is an array. So it means we have more than just one entry. In the case of the short blade, we are working with 3 entries. This is exactly what we did here with 1, 2, 3. And to be sure that we are getting the right ones, then we are just working with that. That, let's see. And we have to loop through that one. We have a 4? No? Wait for... No, curious. Get data table row names. Okay, it's not a loop, it's get data table row names. Yes, here. This is what we can loop. We will have a bit more in the front, so I'm not connecting it yet. We are looping that correctly. Array element. I don't think we need that. Oh, break here. Row names. Maybe we need to. Get data table row. Get data table row. And this is the data table. Boom. Oh, we are slowly but surely getting that. So this is our cute for loop. We are looping through every entry here. Even if there are 200, this is nothing really for Unreal Engine to loop through all of them, because it's just data and it can run through that easily. Outro. Can we break here? Break. Late recipes. Okay, here's the data. So first, before we do anything else, we have to make some local variables. Local variable 1 is sections, and you are a int, because we are counting the sections of our forge state. This is the length. Then we can compare it every time. There you go, here on top. What else do we need? By the way, I'm not looking for any quality or failure here. We are in the first place just trying to get as close as possible to the blades that we want to have. So this will be a little start. I think that's already enough for the start. How are you? Because I like the straight lines here. It looks a bit more tidy. So let's see. Segment targets, yes. Then we have to loop through them. First of all, we can do a segment count. We're asking if this is equal. And I have to make this, how should I call it? Give me a sec. I did something similar lately. I forgot. Making comparisons. Not the cooling, not that. I'll quickly look that up. Let's see if I can find it. Distance. Oh yes, it was in the forgeable component. Let's see. Get hit location, was it here? Get closest bones. Yes, the closest one, the distance stuff, closest distance. We need something similar like that. And closest socket. Let's take this one as a blueprint for us. Closest distance. Closest recipe. Or again, the Razy recipe. You will be afloat. Like that one. For you. Closest recipe name, because we're having the row names here. Row name. This is the exactly. Thank you, Gizzy. As close as we get, we try to tell the how far from the blueprint we are. So let's see, for action loop, we don't need to loop anything here if this is not the same section. So not equal sections. A branch. This makes us just skip everything that is bigger than 3 sections. So much love. Thank you. Sorry. I don't know what's happening here. I'm so in love with you. Maybe it's just my thick socks. I accidentally hit the button. Here we are. No, I'm just touching it with my very thick socks. I'm pretty much sure I just can't feel it. Because the floor is so cold, like freezing cold. I need to wear thick socks. Let's continue here. We got this running. So the first we can check out is this a matching blade type in general? And if it's not, then we just skip this one. If this is one, let's do the comparison here. Loop body, area element, splitting. Bingo, here we are. We're getting the index, and the index will be the same as general in the forged state. Get a reference. I'm using that one. Get like similar stuff. I think we are on our own today. That's fine. I can check quickly. Twitch statics. No, 5 people are watching. What's with the fire? I don't know. I can check for you what the fire count is. It's now 76. It's low for you, no? I don't think it's low. You had to revive it? Oh, sorry. So you saved our fire. Thank you. Thank you so much. Yeah, where have I been? Oh, I'm so all over the place. I'm really sorry. It's maybe the German internet. Now we have to... Can we break this one? Here we are. Now we got the bending. We have the with left and right. We'll just try to stack here to save some space. Poor Porgy, yes. And now if we are close to that one, let's see what could be the fastest one. What is it called? We should just add the tolerance, okay? So this is the recipe, and this is what we have blacksmithed together, what we hammered. So I am checking now first for that one. Let's see if there is some gaps now. Load minus flow tolerance branch. Relative. Distance apps. Okay, let's try something like this. The target value minus current value and apps. Normalize distance. Score, that could be cool. Current value minus target value by tolerance. Let's see. Okay, so the current minus the target, we apps that and divide by yes, and divide by that tolerance part here. Let's see what we get there. Print string. So this is the bending. We will have an append here. Bend. And this. Duration 10 seconds. So now to the hard part. In the portable component, when we go into basic values, pretty much sure we are starting with a 0. For each loop, string, alloys, that's all good. But we don't use the reference. Change width, apply visuals, forge state, change bend. I think we can bring that in here. Change width, apply visuals on wrap. So whenever we change the forge state, it should apply. Let's see. Wrong part. We are working again with that one. Quickly. What was it? Show developer and bones begun. Portable component. This is metal. Forge bones. Forge state. So we have now our 3 parts here. And we are making some stuff up here and see if it's showing up. And let's try maybe the framework, because we are now getting the bending part, but I only did 0.5 minus 1 and 0.1. Do we get any sort of visualization? Yeah, it's doing a bit. Not perfect, but it's keeping our values. That's good. Now for the heat. I'm not sure if the heat is starting with 1. Basic values. Let's see if the heat is heat min max. Heat up rate. Are you here? Oh yes, this one here. You are the value. Are you range? No, you're not right here. Are you in use? optimal capacity, current temperature. Here you are. So current temperature will be set to 1200 for now, just to see if this is doing something. Current temperature, find reference. Wait. Find ref. Event graph, glow, hit quality server, add heat source, current temp, cool down. Okay. Test on that one. Are we getting current temperatures like this? This should be okay for us. But it's not doing anything here. Let's see if the cooling crate does look for something. Maybe it's looking for some sort of special thing on overlap box. Forgeable component. We're looking for that one, right? Maybe it's the authority that's bugging us out here. Current temperature should be greater than minimum heat. We can check on that. If it's believing us when we are presetting that heat. So another print here. Appending. So this is 1, 2. And like this. I really hope we can trigger that while here. This one is hidden, so we can't see anything here. I assume it's maybe because I did something with player controller. Let's go quickly in here. Game logics, PC Campfire. We are restarting here. Must be so sure that the screen logs are shown. Cooling crate. And string, hello. Move. Oh, interesting. Let's do this again. Cool, very cool. You can't overlap if you're not overlapping. That would explain a bit. So, cooling crate. What's your issue? I'm pretty much sure the collision box here is bugged out. So let's show collision. As you can see, this one is completely closed and not open for any interaction. That means for us, I'm going in here, we're going for that box. I'm open that baby. Collision, add box simplified. We're deleting that now. We have this is a full box and I have to create walls out of it. Now that's all part of game development, fixing stuff. I need to reduce the height a bit. So like this. Copy paste. Second side. Hey garbage crafters, salutations! I'm preparing this wonderful, wonderful box. Boom. Make you smaller. Enough. You go here. That's fine. And when we make a copy of that one, too long, my darling. You as well. This one is covered by those edges as well. If we want to be fancy, then we can place additional little boxes on top. Box simplified. Rink. Rink. Just for them. Because we are fancy. 1, 2, 3, and 4. Save this one, and then we try this again. And maybe add that already here. Okay, this is cool. So it did something for us. And since we changed our structure here, we don't see any blade appearing since we haven't selected any yet. So, but we get our prints here. That is awesome. Close all of you. Portable component goes here. A cooling crate does not need those prints anymore. Temperature is okay. No need to change that. Bum, ba, ba, bum. There we are. Cooling crate is good as it is. We can close that because there's nothing we need to do on that side anymore. And we can close this. Get selected blade. Yes, here we are. Check if we can get into that one. Server finish blade. That's too early. Here we go. Let blade goes in here. How long is this? 10 seconds. Okay. I'm dipping. And I'm not getting any output. That's sad. Maybe because our count of sections won't work here. Data table row. So let's have a check here. Again, a print with an append because we are checking on those. And third pin is that one. Oh, it's giving us a 6. Why? So first one tells us 6. Sections. Port state length. We have just 3. Are you really a 6? So 3 here is correct. But I need to see why you are giving me a 6 here. And separately here. Are you really a 6? Yes, but that's not correct. Checking on you. Forgeable component. Forge state. How can we know where this is coming from? Are we creating maybe forge state before that? Find references. Event graph. In the general event graph. Oh, we are adding per bone already at the start. But we should do that maybe only when we are not having something in here. Event begin play, yes. It's doing like that. Get owner, skeletal mesh. Let's quickly do that math part. Get forge state. Length. And we only do that when this is oh no, when this is 0. So when it's empty, then we are filling it. If we are giving it some pre-saved. Oh, you had your burger. Nice. Because sometimes we will spawn blades with data. So if this is 0 and needs a forged state that we don't give them, then we will do that. And bring you here because you are just one parter. Let's try again. Now it's a 3. That's great. So forgeable component thing goes here. Select blade is running greatly. So 3 and 3 should be like this. Now we should get this bendy thing. Hopefully. I will add another one before that loop. Just a simple hello. It's good enough for me. Party hard, du machst deine Schnitte. Oh, interesting. We are not getting the same number here. So let's test our section counter or section comparison. Sections. Oh. Was not the same. Here we are, bending. The bend counter is doing something. That good fresh sushi, maybe. So now for the bending, we know we have different names here, etc. So to be sure we are getting the right data, I need to make another pin. You go in here, my darling. Or another one. With you inside here, and we need the name. Oh, row name. Oh, display name is also fine. And we go inside here. So we know which one is the closest one to what we got here. Band 5.5. Old sickle 5.5, 0, 2.5. Let's see. Sickle. We wanted to make, I thought it was a sickle. Let's quickly check on that one. What did I make? Let's make it perfect. Like 1 minus 1 and 1. And oh, definitely we need to elongate that for maybe 30 seconds so I have enough time to read that. We are looking for the sickle now. Short sickle 10, 0, 0. Why do we have a 10 here? Okay, let's check the numbers. Short sickle 1 minus 1 minus 1. Let's make it right here. 1 minus minus. I want to see what a perfect score is on the bending. Sickle, sickle, sickle. Yes, so there's 0. Means the number will tell us how far away we are. Why is there a 5 on the knife? The knife has 0 bending. That's interesting. Anyway, so the 0 is the optimum. Means we have to go the other way around. Closest is 0. And we will add to the theme. See, what can we do? I want to have 2 loops, or we have to have two different loops. One is per recipe and one is per segment. So let's make another segment, closest segment. And if the segment is through, then we are getting into that one. Whenever we start with a new segment or new recipe, then I will set you to 0. And when we have all of the segments through, then we are comparing it to the other segments to get the closest one. I think that would be the best. Okay, body. Then you can be a big number. You're starting a high here. That should help us. So loop body, we are taking closest segment. That closest segment, and that closest segment with a plus. This is the bending. And then we have additionally the width part, but we are treating it the same. That should work for us. So this one minus this one. Apps divided by let me just add you here. U minus U. Apps divided by tolerance. We make plus plus plus. We got all the metrics combined, just one save. So this one is set then. Yeah, it's pretty messed up here. But I don't think we can make it work better than that. Okay, that is one segment. We are looping through all of them, like the first segment, second segment, third segment. And when we are complete with the recipe, then we are checking closest recipe. If closest segment is less than the closest before, we are branching here. And if it's true, then closest recipe will be set to closest segment part. And closest recipe name. You are not a float, my darling. You will be a name. I think it's name. Yes, change type. Are you name? No, you're text. Text, sorry. Sorry, darling, you're not name, you're text. Oh, we can use the blade ID. That's name, that's name. Then we make that. That's more secure. So we're going through all of them. If one of the recipes is the closest, then we will know. And when all of these are done and we have a last closest recipe name, then we will print that out now. It will tell us what's the most fitting thing here. Duration 20 seconds. There's no other print in here. So by chance we set up something that is looking pretty much like 1 minus 1 minus 1. With the width we can check on that. We make it really perfect on the sickle. 0.3 like, and 0.2 at the tip. Let's make it exactly the same. So this will be like the perfect match at all. And we have to check if this will be recognized as a short sickle. For that, we definitely need to rename radius as, just to be sure that everything is fine here. Oh, I mistyped here. I mistyped everywhere here. Knife is looking good. Got the needle S. Oops. Why did I type the same? Typo here as well. And the equal S. And I hope, fingers crossed, we will get to see proper name here. Yes. Great. Kids bedtime. Yes. Perfect moment. So I will go into a short break. I will say the kids good night. And when I'm back in a minute or two, then we can finally swap the blade for the real deal and then play with different settings to see if we can create different types of blades. So yeah, see you in a moment. I'm back. Kids are in bed. My drink is refilled. We can continue. Bam, bam. So, where we left, we got the proper outcome that we wanted to see here. Thank you, thank you. The next step is to get in there, and we are not getting the name, but the finished blade of that one database recipe. Get database row table. We don't need that node here. Database recipes. Oh no. Yeah, like that. Get that. If completed, we are asking which one is the right one. And then the out row is break late recipes, and what we need is that finished blade, and this will be our output. Here, compile to get it saved here, and now this one is getting in here. Fingers crossed. Let's see if we get any changes. Oh yes, a sickle fell in. Nice. This is exactly what we wanted. All I ever wanted. All I ever needed. Spawn transform location, motion controller. But we are spawning that one as it is. We are not giving it any data from the blade itself. That will be something for later on. So now it will always be created with some basic data and not the data that we need for the proper or spawned item. But at least it's doing this the right thing. Let's maybe do a test and we create another blade and see if we are getting the proper one. So forge state, let's make it new. We'll just delete them. 1, 2, 3. What blade recipe could we make? Let's make the chop. I love the chop. Chop is beautiful. The chop is love. So with left is 0.1, 0.1, and 1. One, 0, 1, 0, 1. So those are all perfect types. Let's test it. Yes. Giving us the proper one. Yes. You know what? We make a nice little test here. No need for you. We can disable the collision now. I will disable the anvil part here as well. So we have a nice visual here. You should be hidden in the game. You are not. Save, yes. Visible now. I put 3 caps in the big one. It was on 10 liters, I think. 3 caps on 10 liters. Yes. The big watering can and 3 caps. Thank you. Easy is now watering my plants and giving them some fertilizer. So I make all kinds of blades now. Different in positioning. That should be fine. And now we are giving them different types of blades. So we have a nice set here. Deleting all of them. 1, 2, 3. Let's make a needle, maybe a gladius. This was 0.3, I assume. Press play. They all look the same. They are not applying to this view. That's no issue for us. Have fun. So forgeable component. You can be bones. Do I use you? Components. Forge mesh. Forge bones. When do we use you? Find reference. Get. Ah, we are only setting them. Make a small difference here. Okay, in our simulation, it does not change visual. At least not as intended. That's a bit sad, so we can't show the preset how it should look like. So you are the gladius. You are the chop, I assume. Yes. Gladius chop. And you can be a knife. So on the left, 0.3.3.1. .3. Wait. Oh, I hate the scrolling. When I touch my mouse wheel, it may change values. 0.1. Now to you. What could you be? make an ox tongue. So 1, 0.5, and 0. 1, 1, 0.5. Nothing. And now for the bendy ones. We can remake the sickle here. So sickle is 1, -1, -1, and with a 0.3 and 0.2. So 1, -1, -1. 3, 0.3, and 0.2 here. Now to my flamey flame. So 0.3 is the overall thickness, and it's 1, -1, 1. One, -1, and 1. So let's see, we got different lengths here with different kinds of values, and if we throw them in, we should get different shapes. So this is an X type, correct? Let's see what you are. Oh, a basic broadsword. Sweet. Whoosh, be gone. Who's next? Boom. Oh, the knife. Beautiful, beautiful. Put you out. Thank you. Next one. Ah, the ox tongue. Super broad and thick at the start and super thin at the top. Now to the more bendy shapes. Can I see you, please? You're a sickle, I've seen you. Here we are. Sweet, sweet. And the last one should be a snake-like shape. No. I maybe did something wrong here. Oh, yeah. I was right. I was right. It's working. Twitch, clip that. Cool. So basically we can already... What you? What's to test here? We can create all sorts of blades now from just one single blank here. So this is working well. There's still some tiny things we need to adjust now, and yeah, the basis is done. This is wonderful, wonderful. So our recipes, they work. I just think we should duplicate this one. Can I do that? Add a variable. Finished blade mirror. You're right in between that. And you're an actor. That's reference, perfect. component, save view. Now the blade recipes, they have this mirrored one here. In case we have like a mirrored true. Shop mirrored. There's too much space here. So, and whenever here is true, then we need a mirror. Flameburger mirrored. True, you're the knife. Mirrored. And the sickle. Mirrored. So in case that you have a mirrored version here, then we have to see if it's maybe the opposite around. Let's see how we can do that. Portable component. So we are in the select blade part here. Segment mirrored. Let's make this a local variable. Duplicate. And we make one extra step here. Go below that. If allow mirroring, we are asking. Branching. If this is the case, if we are not branching, let's put you right here. If you are not branching, then we are just getting this as the closest segment we got. That's all fine, all good. If we allow branching, then we have to allow all the bending in the and all the width in the opposite direction. And then we have to compare which one is smaller, and this will be closest segment we set. Are you less? Make you, because the other set will be up there. True. And false. Now for the second set. We can copy all of them up here. What I need is that tolerance value. And now all those pins. But we have to see, because one set will be negative. We have to multiply them with -1. So let's see. We are going. This is the fourth section. Bending -1. Let's start with the bending because this will be the easiest. So if that one -1, you go in the upper one? Yes. You go in the upper one. Hope this will do. Like if the bending is directly in the other direction, then this is the opposite, like the mirrored width. Yeah, like this. Could work, could work. And you go. I think then we have to twist left and right here. To get like the opposite side. And this is now the comparison that we got. So, oh, sorry for one. You go in here, you go in here. If this one is smaller than that one, true, then we are taking mirrored. And if not, then I'm taking the closest segment. And I have to make outcome mirrored with a boolean. This boolean will be by default false, but we are setting it right and wrong here. So if I now the mirrored one won the race, not set. I want a branch, please. Branch. So if it's failed, then we are taking the original one. If the mirrored one won, then we are giving back the mirrored one. And to test that, I think the first one was the chop. 1, 1, 1, yes. Let's just work with this one, and I'm trying to forge both of them. Copy of that one, and I'm reversing the numbers here. Like you are just 0, 0.1, 0, 0.1. You are 0 and you are 1. Let's see, we should get two of the chops, but one is mirrored and the other is not. Fingers crossed. Okay, so we're getting one. We're getting 2. Let's check on them. Both are chops. Why? Let's follow Blade recipes is okay. Forgeable component. Outcome mirrored. Make a print here. Font mirror red. Print string. Font normal. Then we'll see in the end. Get a true or false, just to be sure. Mirrored, it mirrored. Check on here. We are in the chop, and here is blade as chop mirrored. Font normal. Font normal, font mirrored, font mirrored. Let's redo that. It's set to false. The last one it found was normal. But I think we made a mistake here. Let's see. Blade recipe. Did we do it right or not? Closest segment. Saving a segment. We're doing the normalization down here. Let's I think we need to make that here. Close the segment. Mirrored. Yes. Close the segment. Mirrored needs to be saved here. Just saving them. If it's true, so if we're getting both, we have to save both first. Adding and normalizing both. Thank you, Gizzy. And we're doing the comparison down here. Closest recipe, yes. So in case that we have a mirrored case, we have to do that test first. Here. You, my darling, go here. So if it's not mirrored, then we just follow this path. All fine, all good. Nothing to worry about. But if we have a mirrored case, then get we do that one. We're branching to see which one is the closest one. If it's the closest segment, then closest recipe. Will be that one. And now we are setting outcome mirrored no. I'm just finished with that one. And if it's this case, then we say it's mirrored, and we are taking in that one. Maybe here. Let's test it and see if we can get any errors or something. We need to repeat on the terrace. Yes, definitely. I tell you. So this is false because this is the original unmirrored one. And now we should get hopefully a true. Not. Oh, we got something completely different now. It was not getting it. Closest recipe. Oh, I forgot one step. Set. Now we have to compare that here, sorry. Closest recipe. I forgot a step. Are you less? Then branch. We go, wait, can shortcut that. So our closest recipe is already set like that. Second test. Unmirrored. Yes, this is false and we are getting that chop. And this is false and we are getting the wrong blade. Because it found something else more suitable. So let's compare the outcomes here. Maybe I did something wrong on this side. We don't know. I think that one is working pretty good. Closest segment mirrored, yes. So what if we are going for something that is just bent, so we can be sure that that's a different case, and in this case we are with different width. Animals not needed anymore. I think we should make one here. Condition. Oh, my condition is gone. Close a segment, close a segment. Oh, please don't break. I have 12 unsaved files. I'm afraid now. Easy. Oh gosh. Oh my gosh. I forgot to save so many files. Good. So there was one error here. Was? Yeah, Unreal Engine just stopped doing anything for several seconds, and I panicked. So, but everything is fine again. And yes, I saved everything. So let's have another test and see. This is again a blade. Let's check your data just to be sure. Portable components 0.1, 0.1, and 1, all on the right side. This segment, if you're mirrored. We're checking here the closest segment, and we look if the closest mirrored segment is the shortest. I think we have to print out both. First of all, I need to know the name again. Plain name. Oh. I need my appendix. So we know what we are checking right now. So this is about the name. And then we are checking for normal. So the amount of normal that we get. This is closest segment. And mirrored. I want to see you for 30 seconds. We are looking for a chop. Battle axe, knife. What's here? Normal 12 to 1. The same. Short knife. Maybe I did something wrong here. Let's quickly check. Closest segment. Oh yes, we're doing something wrong here. In this case, we have the closest segment mirrored. That's our basis. We were adding to the wrong side. Try again. this is a proper 0, 0, 0 on the mirrored side. This is spaghetti code. Like, this is literally spaghetti. But I don't know how to make this more appealing. Because there's so much. But at least you can highlight single strands and see where it's going. Okay, so we know in this case the mirrored one is a proper 0. No German order, no. Now we have to go here. So closest segment and closest segment mirrored. If outcome mirrored. Oh, there's the wrong one. Low mirroring. This is the right one. It's so many mistakes here. It was not possible to work. Where it is. Did we lose it? It just got kaboom. Let's try again. True. Okay, we got a true here. So you want to get the mirrored one, but we are getting a none. My code looks like a bag of potatoes. I got too many cents. Too much. Is it too much? I don't know. I'm not a potato. Maybe you catch potatoes sometimes. But what do I know? Where's my soil? No. Okay, let's see. We got that one. Finish plate mirrored should be. So we are here in true. We can delete you because you're already connected. Maybe print now a string of dash baby here to be sure that it's properly in there. Oh, nada. Nice. Then give me at least a display name so I know what you wanted to show me here. Oops. Oh, again, a short gladius. Why? Why did you want to do that? What are you doing here? Okay, I destroyed it. I did a mistake. No, let's see. Closest recipe name. Closest recipe name. Bam, bam, bam. We are writing closest recipe here. And here should be the closest segment. Closest segment. Yes, I did another trailer here. No, not yet, but right. Closest segment. It. You're just fine. And we need to rewrite here with a mirrored one. Bum, 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 bum. Because we're checking here for the closest segment, not for anything mirrored. Let's check you again, my darling. Yes. You are the mirror chopper. Yes, 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 yes. Okay, so the width mirroring is already working. Let's make a sickle. Sickle is 0.3 and 0.2 at the tip. 1, 2, 3. 0.3. You get a 0.3. You get a 0.3. And you. Last but not least. 0.2. 0.2. And now for the bending. 1 minus 1 minus 1. 1 minus minus. Since we are lazy, I just copy that one. Oop. And we have to mirror only the bending. Save. Thank you, Gizzy. So let's see, do we get a sickle here? Yes. You can see the model here. So this is a basic sickle. No mirror in there. And now check for the second one. And we get the mirrored one. Yes! This is good. Good start, good start. Now what we have to do is, I have 2 tasks. One is taking care of the alloys, but we don't have any alloys starting in Naleka. We only have sand here. Sometimes we get a moon, but this will be just pre-made stuff, because the alloys and alloy mixing will be something for the second blacksmith building you will get to see in Zemia. So what else can we do now is we can take care of the blades themselves. So let's see, plank master. To get in here, yes, here we are. Blade base. Radius. Let's throw this baby in here to see if it's there and working. Yes, boo! Cool. I was not sure if this one is still alive, but as you can see, this one is a perfect shape here. We got this little tip. This is the so-called stabber. It knows where the pointy end is, and it will explain me where the step goes. And we have this damage dealer box. This is just a simplified box that will cover around where the horrible part of the blade goes. This is easy for that one blade, but we will have to do adjustments for the other ones. So let's start here with the chop. And to be honest, I think this is the part where the damage comes from. So we will definitely have to adapt and make this one the damage dealer. And not that part. can't I? Oh, great. We are stuck here. Compile and save. Now we are here. This will be the part where you have to hit your enemy. When we are done bringing up all of these boxes where the main damage will be dealt, then we can talk about different damage heaviness, like how much damage one thing can do. Do the same here. You belong here. You, my darling, you have to go here. Compile. Yeah. Bed back. It's not hitting too early. Save and next. This will be a bit more difficult, I think. We should maybe work with different parts. Like to begin overlap, yes. Maybe we should add in there for additional damage dealers, because we have more than one maybe here. Let's do some free rotation. Whoops. Second damage dealer. Hello? Oh, up there. Nice. Why are you there? And what's your issue? Do some shrink, shrink, shrink. Are you thicker than the other one? A bit. As you can see, I'm just giving rough shapes here. Already enough for what we use here, for what we do. More rotation. This. Shorten that, pull that out. So this is roughly where we meet. I'm going into the blank master here. We're looking inside here. Event begin play. No, the blank master. I'm in the right one. Blade master. Damage dealer. I will just copy that behavior. And we do that with the second damage dealer here. Event on component begin overlap, and on component end overlap. This is the trigger that we're using for the first one as well. I'm just collecting all of them here. Here in between. Then I have to check which one is the upper one. The end overlap is above. Now we are going other actor goes in the first one, and other component goes in the second one. Other actor, other component, boom. And here we have overlap component, goes all the way there. Selected asset, what goes in there? Oh, other component against other component. Okay. You go here, you go there. So overlap is only used there. Other actor goes into that bottom. And the second one goes into the velocity component, other actor part. Yep. Then we have restored that. Save. And as soon as we create the damage dealer on the other side, then we are fine. Let's open you. I need that damage dealer 1. We just add you here. See if I can just turn you around like that. Should we turn you around like 1, 2? Good enough. And now I can completely copy that part because the damage dealer has the same name. Here it is. Let's go for the next one. Gladius is good. Blade knife will be pretty easy, even though there is some mirroring in there. But in this case, we just bring that one to the front. I want to make it a bit shorter. Yeah. See ya, Zeki. Done. The needle. Since this is of a stinger, I don't know if we should make the whole side part of the damage dealer. Easy, what do you think? Should it do damage on the whole side? Okay. Ox tongue. This will be fun now. I hope we can live with just one. Yeah, the needle is a rapier type. More like a round version of the of a dagger. Because it's just a round needle type. There is no proper blade. Sorry. Like this needle. Since this is a stabber, I think it should be hurting there. Okay, only the tip. Gotcha. Saved. Now to the ox tongue. This is a heavy boy. Maybe, I don't know, since the angle is not the same. Thought of maybe rotating. But it won't give us the same angle. Maybe I have to make two. Like this. This maybe damage dealer one. Oh. Why? And voila. So those are the blades. I mean, if you are hitting them with the side, then you will get that either way. Okay, it's not giving me that. Sad. I will have to implement a little helper in here, just to be sure that you're not dealing double the damage when you manage to hit something with both sides at the same time. For example, when you hit it with the side, then both of these will maybe touch whatever you try to hit. We will see and find some solution for that. So be aware there is a little exploit here until we fix it. Pickle now. Oh, beloved stabber. We go here. here. That's good enough. Save. Something like too short. I will see if we'll be able to create better shapes for those. Those are box collisions. I don't think there are similar ways to do this without going for that shape. Since we want to have distinguish sets. Great, you are now copying perfectly, thank you. So here we are. View, copy. Copy. Add event and overlap. What's on top? I think yes. The actor goes in here. Other component goes in there. Begin and begin overlap. So other component goes all the way here. The actor is in there. Other component in there. And other actor all the way there. Nothing is connected here anymore, so this one is good. Damage dealers being dealing. I'm already copying that because we will mirror that baby or mirror it. Let's be super lazy. I will delete. Very clear. Okay, clear. Save. I'm not using it anywhere else. That means I can maybe delete that one. Oscillate, will elaborate. Okay. It was crashing, but at least everything was saved. Send and restart. I mean, we are nearly done anyway. So let's chill. Have another sip. Stay hydrated, guys, girls, and everything in between. Thank you, Gizzy. What chill stream. No drama. And I really managed to finish that feature. Oh, enjoy your cider. I got my holy iced tea. Let's move my window. Window. Ah, there it is. We are inside here. Yes, I want to open my blueprints. Let's see. Can I delete that one? Maybe. No, I can. Good. Because I'm lazy. I'm duplicating that one now. Again. For your mirrored. Save here. And we're here in the sickle. Sickle mirrored. Save. Because now all the work is done and I have to rotate everything. That's my main idea. It's my blade. Let's do the 90 degrees. Enough for me. Wait, I have to activate them first. Here we are. 1, 2. You go here. You turn sideways. 1, 2. That's way faster than doing everything from scratch. So 1, 2. And you, sweetie, you can go there. Oh, that means all blades are basically prepared to work. Let's close everyone. Forgeable component, blade base, blah blah. So for the damage, let's talk about some basic damage that we start with. I have a damage component here, and for this kind of blade, the short one, I just put in a 13 for damage. Now we can do first comparison in damage types, like how heavy this will damage. And we have a sharpen bonus. I think we should keep that sharpen bonus because it will just add a bit more to the whole thing. And now we can say maybe the plus minus how many damage each of them can deal based off this 13 for that gladius part. Let's go in here for that knife. Should it have the same damage as it's the gladius? They are pretty similar in weight and in size. Like the width of the blade is pretty much similar. It's a bit wider here, but a bit thinner there. But overall, I think it's the same damage class. Okay, so we keep you. Knife is good. Maybe a bit less. We can take half off. Let's make 12.5. 12.5. Saved. The needle is the by far lightest one. Window, viewport. It's a stabber, but it's in comparison, I think it's pretty fast. We can maybe give it a higher sharpen bonus. So yeah, you're penetrating like really heavy and deeper. Let's maybe give it a sharpen bonus of 15, but 10, I would say, for the base damage. You don't have to do swings like that. You can really just bam, 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 step, 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 step. Forgot to say be right back, but I left for a while. What I do, I missed. No, I don't know. Yes, you missed everything. Like the answer to everything in creation. Yes. And I sang the best song in the world. Tribute. Right now we are playing with the numbers. We're trying to select some base damage values for the first starter blades. And now it's 42. So, for example, this baby here is striking with a 13. And it has a sharpen bonus of 10. Then we have that knife shape. Similar size, just one sharpened side. We are going in here with a 12.5, same sharpen bonus. And this is a special one. It's needle type, just a stinger. We are starting here with a damage of 10, but we're giving it a higher sharpen bonus. Let's continue with that bestiality, the ox tongue. This will be a heavy baby. I think we can go in with a strong 15. Definitely. Same sharpen bonus, I would say. Because the overall base damage is already like higher by 2. I mean, these are all these small starter weapons we are talking about. Sickle is interesting. We got this curved blade. It's thinner. Maybe 12? We can go lower, maybe even 11. Oops. But give it a higher sharpen bonus. Because this one is living from its sharp edges. So 11 and 13. 11, 13. Save view, all saved. I'm not sure if you answered my question, but I asked what color the soul alloy will be. What soul? can show you the osals, like the metals we have, when you are taking them as pure ones. And as soon as you start mixing, the colors will mix in between. Like we have this, we start with the lowest one. This is, you're saying something along the lines you could use souls in alloys. That's something completely different. But the alloys themselves, they have that color. And we are not changing the color by different ingredients themselves, but we can create dyes for the alloys. They are on alchemy level. This will be added later. So we will have some color multiplicator, color changer. If you're not happy with the color as you have them here. Did I do the damage here? Yes. So you're done. What else do you have? Oh, that was a failure. Blueprints, items, blacksmith, blades. So we got all of them. Now for that flame shape weapon. It's lighter and thinner at the top. Maybe move you in here. So it's definitely lighter than the gladius. Damage. But we could give it a heavier sharpen bonus because it's so pointy. Maybe something similar to the sickle. Let's give you 11.5 and a 12. They are all pretty similar, since they are they're from the same base shape, like same family. Now to my very favorite one, because I think it's looking so ridiculous. This baby. I think it should get a super high damage in comparison, because the damage dealing part is pretty small and it's pretty heavy on the head part. The ox tongue is a 15, so this one should be at least a 15. Because you put all the force in there. Kizzy, what do you think? Maybe a 16? One more than the ox tongue? Yeah, it's the smallest of the great eggs in comparison to the ox. The ox is pretty heavy because it's thick, but most of the mass is pretty much near your hand, while that baby here has the most mass around the most weight tip, I would say. And if the ox tongue is having a 15, yes, 15 of damage, then this one should be at least 15, I would say. 18. Ooh, this is great. You're giving a great benefit because the heaviness of the tip plus the super small area where you hit. That's worth it. Cool. I love it. So basically that's possible to do now. You can't see it, but I will start to package the project. I have to do a little update here. Let's redo the game logic. Campfire, we need to reconnect that. Step 1. Do we have already hammers in there? Let's quickly check for the level. Islands, main island. It's the Wuchtwaffe, it's heavy. Slow, but deals more damage, yes. Oh, speaking about slow. Later on, when we're doing some intense testing on like combat and stuff, we will have to play with weight. Like as you said, this one is slow. Right now, all of them, they are moving with the same speed, but we can later on make some of them slower, like heavier and more forceful. But then we have to go like a task force in there and just test only the heaviness of a blow. Otherwise, some things are too powerful. Yes, definitely. I don't want people to swing like the big battle axe, like it's just some piece of paper. We will do something, but we are lucky we have our grip component, and that grip that will help us. There are some constraints, like making things heavier, slower. Yet another lesson learned from Township, yes. To be honest, the game itself was the best teacher you can imagine when you're thinking about some sort of VR game. Have a quick check out there. What do we have in place here? We got these thingies here. Okay, the heat source is there. This is a proper anvil. We got the cooling part here. This will be fun, like running all over there. We will have to maybe adjust things. I thought the cooling crate over there would be cool because I already placed some mud here. It's looking like some spilling were done. But I assume heating up your blade and then running over there can be a bit tearing. We will see. Blankets. So we don't need you. The proper hammers are not done yet, but the other ones will do for now. Blueprints, items, blacksmith, hammers. I'm going to make tongues to hold the metal. Oh, you mean I don't think if we can do that in VR. Like an object you're holding to hold another object. I know it's ridiculous to touch something that is that hot. I really don't know an answer. Maybe we should work with something like gloves later on. That would be more reasonable in my opinion. Maybe I should put you elsewhere so people should start to look for them. Where can I put you? Where can I put you? Maybe one is here. Sitting next to those items. I know there are so many cool things, but cool things often mean that we are having issues. Can I swap levels? The window levels. I'm switching into that level. XV. So those for now they are tied to this place. They will get spawned whenever someone is entering this place, and they despawn when you are leaving this place with them. Place someone here. But for now, for testing, they will be fine. Later on, I will implement a logic where Marek, the blacksmith of this blacksmith building, will take care of his own hammers that he is just like sharing with you, and they won't be able to leave that area. They will just come back and just stay somewhere. But for now, for testing, this will be good. Blanks. Okay, just that one. I'll just place some of them here. Play and test. Make test run if they are falling through. No, they're looking great. You are here. Oh, you're disappearing. Are you tied to something, my darling? Rhinestone. You're tied to that blacksmith area already. Okay, good. I'm fine with that. And let's put you on top of one of these crates. So here we are. So in theory, it's testable as soon as we publish that part. Before we do, levels. I need to go in there and raise the number a bit, the version number. Taking a while. Preparing shaders and everything. Here's my little version number. So I can keep track of things. And with that done, let's start to package the wonderful project. Starting to package. Yeah, I'm not sure how much will survive the multiplayer, but at least we have something new to test. And then I think when this part, like the finishing of the blade itself, is done, then I will step back from blacksmithing for a week or two, because yeah, I've done that pretty long now, and we will do the handle making and handle pommel blade connecting another time. But the next thing I really want to do is to get into the magic system to make at least the foundation, so people have two different things to test then, and not everyone is into blacksmithing, so we have another thing for a broader audience. And I think the magic system that is how should I say it, the groundbreaking work was done by a community member, which is so cool. That should be definitely honored and made into reality. So yeah, when this is done and when we are not too buggy, too laggy, then I will continue with magic. Yes, I know. Oh, the packaging failed. That's sweet. I know overall storage, but this is some heavy thing. See, where do we have? Request failed. I need to fix something to get that running. What attempt? Messages. Interesting. Log streaming error, couldn't find file package. RAS. Interesting. Okay, so I will have to fix one how should I say it, one reference, but it's already late, so I will fix that tomorrow and present you the update after that, because time's already up, and yeah, it's time for Genki to go to bed. But yeah, I think we did quite a lot. I hope my stream clip is doing well, so I can present it to community later on. That's it from my side for today. Bum, bum, bum. Thanks for watching, everyone. Thanks for being with me here. Another, what is it? 4 hours again or something. That was quite a lot again, but I think it was great, and it was nice. We did quite some things, finished that part, at least in theory, and as far as we could test it, so that's a big thing. Clap clap. 356, yes, like 4 minutes to just yap and tell how much I love you guys, because yes, everything here is just possible with your help and your support and your love here. I'm the one that is like doing the coding stuff and like the yapping here, la, la, la. But the main part is really the community who sticks together, who has ideas, who just promote me with your systems and overall your love for VR gaming. La, 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 la. Like blah. No. But enough from me. If you not already have, please join our Discord. I wish you a good day, good night, good whatever time zone you are. See you tomorrow with the next update, and